Okay, so hey guys, welcome back to another SAT video. Today we'll be doing some digital questions from the first practice test. So the first question says, a business owner plans to purchase the same model of chairs for each of the 81 employees. The total budget to spend on these chairs is $14,000, which includes a 7% sales tax. Which of the following is closest to the maximum possible price per chair before sales tax? The business owner could pay based on the budget. So we should be able to recognize that this is an inequality because he says that the total budget, right? The total budget to buy these chairs. It can also be like a regular equation. It could be, so what we're going to do is we're going to do less than or equal to 14K. Okay. And you know that it's 7% sales tax included in the 14,000. It's not just 14,000 for the 81 employees. So we do 81 times 1.07 because it's not being deducted, it's being added. So it's going to be more. And then P is the price per chair that we're trying to find out. So for every chair, this equation is saying that for every chair that you buy, you'll be paying this much amount right here. Okay, and you have 14K to spend. Now the question's asking, what's the maximum possible price per chair, right? And so we will be dividing 81 times 1.07 with 14K right here. So then you get, right? And then once you do that and you round it 2 decimal places, you get 161.53, which is our answer right here, B. Sorry, on B right here. The next question. In a triangle LMN and RST, angles L and R have measure 60 degrees, LN have 10 and RT have 30. Which additional piece of information is sufficient to prove that LMN is similar to triangle RST? So first, we can just draw out our triangles like this, right? LMN and RST. These are not drawn to scale, by the way. So we can do L, M, N, and R, S, T. Okay, and what they're saying that L and R both have the same measure of 60 degrees. And Ln is equal to 10 and RT is equal to 30. Each additional piece of information is sufficient to prove that LMN. Okay, so right away we should be realizing that we're trying to trying to prove that this triangle is similar. It even says in the question, and for that we need to be knowing theorems such as side angle side and angle side angle, and so on. Okay, and so as of right now we have an angle and we have a side. Okay, to prove that these are similar, usually we need to know that all the angles are equal to each other, because let's look at the questions and we'll understand better. There's an answer which says Mn is equal to 7 and St is equal to 21, which does make sense, which is true, but it doesn't help us prove that the angles are similar. I'll tell you why in a sec. So we know it's not A because Mn and St are going to be the same, which makes them not similar. The measure of angle M and the measure of angle T are 70 and 50. So right here 70, right here is 50. That makes this 50, right? And that makes this 70. Okay, so that means these two are equal and these two are equal. Okay, and M and S are 70 and 60. M and S should be equal to each other, so we know it's not C. Now we're stuck in a predicament. We don't know if it's B or D. But what we can use to deduct this is that if M and N and S and T have a ratio of 1 to 3, that might prove it, but the angles could be different. There's a possibility of angles being different. This is why D is the correct answer, because if the angles are the same, right? If the angles are the same, that means that the triangles are similar, because they already gave you a side of 10 and 30, which means it has a 1 to 3 ratio. The last one is, in an xy plane, an equation 2y is equal to c for some constant c intersects at exactly 1 point. And this is important because exactly 1 point, only 1 point you can always intersect in a parabola is its vertex. So essentially we're trying to find the vertex. This for next. If the parabola has equation y equals negative 2x squared plus 9x, what is the value of c? So we know that 2y is equal to c, and y is equal to minus 2x squared plus 9x, okay? And right now, we can find the vertex by just doing negative 9 over 2 times negative 2, which is 9 over 4, okay? Once we get that, yeah, so now that we have the x value, we plug it back into this equation, which gives us the y value. So then we'll find the vertex, right? We'll find the vertex, and once we find the vertex, you know that the y value, you can just make c is equal to the y value of vertex. So let me just show you what it would look like on a graph. Let me just erase all this. So, erase this too. Alright, so this is the graph we're trying to solve for. Just say this is our graph. Okay, for example, now when we're doing negative b over 2a, we are creating a line of symmetry that goes exactly through the vertex. This gives us the x value, okay? And once we plug it back into the equation right here, right, we get the y value. And so it intersects at exactly 1 point, right here. And that is this y value that we're trying to solve for. So that's what gives us the answer of C.